Welcome to the Test Guild Security Podcast, where we all get together to learn more about security testing with your host, Joe Colantonio.
Hey, it's Joe, and welcome to another episode of the Test Guild Security Podcast. Today, we'll be talking with Dr. Arash Rahnama all about data poisoning, the emerging momentum around adversarial AI, and the need for embedded security and defenses. Dr. Arash is the head of applied AI research led at Modzy, where his team focuses on designing novel neural networks to detect data poisoning, developing robust neural networks to defend against adversarial attacks, domain adoption, and AI explainability. Dr. Arash has more than 12 years of research and professional experience in computer science, and he's published numerous research topics, including theories for defending against adversarial attacks, encoding brain networks using unsupervised deep learning, and much, much more. He really knows his stuff. You don't want to miss this episode. Check it out. It's no secret that the number and complexity of applications are growing. But what is alarming is that 90% of security incidents result from exploits against defects in software. The need for better application security has never been higher, and Micro Focus Fortify is here to help. Fortify is the recognized market leader in application security, and it is the most comprehensive and scalable application security solution that works with your current development tools and processes. With Fortify, you can start security applications in a single day, including custom code, open source, or commercial components, and scale as your needs grow with an on-premise, as-a-service, or hybrid implementation. Check them out. Head on over to microfocus.com/app security. Hey, Dr. Arash, welcome to the Guild.
Hi, Joe. Thanks for having me.
It's great to have you. I think this is a really hot topic. I come from an automation testing background, and I know AI has been slowly working its way there. And security seems like it's a now newer topic where AI is actually making a play. So I'm really curious to get your take on this. But before we do, is there anything I missed in your bio that you want the Guild to know more about?
No, I think you covered everything. I do lead applied AI work at Modzy, where Modzy is an AI software product where we developed robust AI models that can generalize to different data sets that clients may have. And you can actually utilize the type of AI models that we develop. We also provide an AI platform where you can run your own AI data science models on your own data sets. We provide the security and governance you may need in that case.
Awesome. So I definitely want to drill into a little bit what Modzy does later on, because I just want to work our way to it to let people know why they need a tool like Modzy. So first, I was watching some webinars on your website, and I heard a term I haven't heard before, which is shadow AI. And I think this ties into security. So at a high level, how would you explain what shadow AI is?
What we mean by shadow AI is that distance between what the data scientists develop in the lab and the actual product that the company may need. There's always this distance between what I test in my lab on my own data sets and scaling that and turning it into a product that you can actually use in larger scale data sets and in large scale applications, which is one other thing that Modzy enables for users.
Nice. So how does shadow AI maybe expose companies to security risk?
So just like any other type of, like, for example, cybersecurity, all these AI models are also vulnerable to attacks, getting hacked or being misused. So when you developed an AI model, it's usually designed to perform a specific task. So you train it on a training data set, and then based on what it's coming across during training, the model learns to make predictions. And then you take that out and you develop the final product that then is run on your data set during test time inference after you've deployed your AI model. When you do that, these models are sometimes vulnerable to noise, which means you can add engineered noise to the input and completely fool those predictions that the model was trained to make. And this is the field of adversarial AI. It's possible for a bad actor to look at your AI model that you've trained and developed and deployed and figure out how to change those inputs. So during inference or during deployment, the model is not performing as it's designed to perform without the user noticing. So that's the tricky part. These changes are so small and so easy to make and so hard to detect that it becomes very problematic for a lot of different applications when you think your AI model is working, but it's not really, and it may take you some time to notice that. So you're relying on these predictions. You are listening to your AI model, but what you're looking at in terms of the information you're getting back, they are all compromised.
Nice. So as I mentioned in the pre-show, I am new to security, and I would think AI also is kind of new for attackers. I didn't know they knew ways to exploit it yet, but I think once again on your website, I heard Gartner recently said that in 2022, 30% of all AI cyber attacks will leverage training data poisoning. So that sounds like a common attack. For folks that don't know, then what is data poisoning?
Data poisoning is one of the subfields of adversarial machine learning. And what we mean by data poisoning is when at the very beginning, when the data scientist starts to train their models on the training data sets, those training data sets are compromised by the adversary. So the example I gave you before, that was more after deployment during inference. Data poisoning happens in the lab when you are training your models on a training data set that you trust, but in fact that the data set may have been compromised by or poisoned by the adversary. And what happens there is that you train your model on that poisoned data set. Everything goes normally, so you get the performance indices you expect, the predictions you expect on the test data set. So as a data scientist, you would not notice that something may be wrong with your data set. But once you package that model up and you deploy the model for your use case, the model is compromised in a sense that it may underperform in specific cases that the adversary was interested in when they poisoned your data set. So still, it's performing well 80% of the time, but for that 20%, those specific classes, the model underperforms. And again, it becomes really hard to detect because it's just so hidden under the processes that the model is producing.
Why would someone want to do this? Is it like corporate espionage that you may want to attack your competitor to make sure that their AI doesn't work as well as yours? Like, why would someone perform this type of attack?
Yes, so the objective may differ case by case. So like when you're talking about autonomous cars, it's possible to hack these image classification models placed on a lot of like these different autonomous cars or driverless cars where they're detecting traffic signs, for example. So if I'm a bad actor and I want to cause an accident, it's very easy to hack that image classification model. And then obviously that's my objective. I want to compromise the security of the driver. And this is actually something that people have shown as possible. It's possible to hack image classification model on a driverless car so that it's not detecting the speed limits, in which case you can see or a stop sign. So the car actually does not stop at an intersection, and then how that can lead to an accident. In other cases, you may want to create misinformation. So for example, so if there is a drone that's mapping an area for a specific goal, for detecting objects, maybe summarizing what's going on in a specific city in terms of population, or farming in terms of different applications, basically. You want to have an idea of an area, and the drone is flying over and you have your AI system placed on the drone to detect different objects in that area. It's possible to poison either the training data set or the model itself can be attacked so that the objects detected, or that summary statistics that the model is supposed to produce is incorrect. So the information you have is incorrect. So that can be another objective. They're different, just like cybersecurity, how like malware and hacking and all those things have been common for the last 20 years for different objectives and different goals. The same applies here too for adversarial AI. And it's a newer field. It's still nascent, but it's very similar and it's growing.
So because it is a newer field, are there any specific, security controls you can use to reduce the impact or likelihood of data poisoning or adversarial attacks?
That is exactly what we're trying to do. So it is possible. So just like how the adversarial, the offensive side of the research literature in the AI, in the field of AI is growing at the time, the defensive side of it is also growing. So people are coming up with different defensive solutions as to how to protect your data, protect your AI model, or protect your data science processes so this doesn't happen. And that's what we take seriously at Modzy, and we're trying to develop solutions for that specifically.
Nice. And I think you did recently present your work at the Computer Vision and Pattern Recognition Conference. And you provide a new definition for AI robustness and propose a new training to help improve the learning robustness against such attacks. So, can you just break down that research to a level that people can understand that maybe kind of new to this area?
Sure. I think that your audience would appreciate this actually, because what we did, we connected the science from automation and robotics and control theory to AI to develop a new way of training for AI models that lead to more robust systems. So I presented this work at CVPR last month. The main idea behind our work was that when you go to automation and control theory, in the last 100 years, we have been developing models that are robust against external noise and disturbance. So if you're designing a factory robot, for example, you define specific goals for that robot, but you also design it in a very stable manner. So if something unpredictable happens, the robot can deal with that. We looked at AI systems in the same manner as well. We said, okay, so the AI system itself is a box. It's a black box. It's a nonlinear system. Once you deploy that AI model, it has a certain objective, but at the same time, it's dealing with environment, external noise, external disturbance. So that adversarial noise or adversarial attack can be a subset of the external noise. So you have to develop your model so it's robust against anything unpredictable that may happen so that it can fulfill its objective in the specific task that it's assigned to. So we brought the science from automation, how we define stability and robustness, and we applied that to AI systems, and we developed this new way of training based on backpropagation, which then leads to the same robustness indices that we are familiar with in control theory, but in the field of AI systems and AI models and artificial intelligence. And we could show that we can actually outperform a lot of other solutions in this area and develop models that are really robust against adversarial attacks.
How much training data needs to be poisoned before it's noticeable during inference? So does this help catch it earlier, or how much? Does that make sense? Yeah.
It's a very good question. Let's think of image classification, for example, because it's very simple to envision how an attack happens for an image class. But this can be applied to signals, to video, to language, any other type of data source. So in the case of image classification, how these attacks happen is that the adversary changes 1 or 2 pixels in the image in places that you wouldn't notice. So you and I, if we look at that image, which is adversarial, we would not notice that this image has been changed. So that noise is added to some of the pixels, maybe less than 10% of the pixels in an image. And then once that image is sent to the image classifier, then the classification decision is now incorrect and you get bad predictions. So what our approach does, it makes sure that if there are only 10% of the pixels changed, nothing bad happens, basically. For the adversary to be able to fool the network that we have trained, they will need to change many pixels in the input, in which case then we can detect that. So our solution makes it much, much harder for the adversary to hack into our inputs and fool our AI systems.
Great. So I actually got some of these questions. I posted on Twitter that I was interviewing you. I got some really good questions from Bill Matthews. Just want to give a shout out to Bill here. So this actually kind of goes in really nicely to one of the questions he asked. You brought up an example of images. So he said most people assume adversarial attacks on images, like you just brought up. So how significant is this threat to other inputs, such as voice input?
Oh, it's very serious. So for example, I know that a lot of these voice-based systems, such as Alexa or Google Voice or Siri, it's possible to introduce. So when you talk to Alexa, you can say, "Hey, Alexa," and then you ask your question. It's very possible to add noise to random signal or music and make Alexa listen to you. Instead of turning on by, "Hey, Alexa," now the system is turning on by music or random noise. Or in the case of language, for example, we have a lot of natural language processes based models where you want to summarize a large amount of text or documents. It's very possible to introduce typos to words in the document and then mislead the model into producing results that are completely unrelated to the context of that document. So yes, in other cases, people have shown that this is possible. Voice-based models, language-based models, any signal. So it's not just voice, anything based on signals. And people have shown that this type of attacks are possible. Yes.
So let's get into some solutions. I'm sure there's a few out there, yours being one of them, the Modzy platform. So how can Modzy help with some of these type of attacks we talked about so far?
So we have a couple of different solutions. One is the way that we train our models is just different, what I explained earlier. So we try to implement that for the models that we have on our library for our users, clients to use. We also have developed a new solution that does data parsing and data filtering. So one of the interesting solutions that we've developed over last year is to look at how the adversary would think and try to model that thinking and use that to detect attacks. In other words, instead of defending by training the models, let's be more proactive and predict how an adversary would hack your system and model that behavior, and then use that to filter out bad inputs. So before you do your training or before you run inference on your data, you can use our data poisoning filter to filter out any bad example that may have been compromised by the adversary. So this solution that now can be attached to any type of AI model, signal-based, language-based, or computer vision models, whether they're Modzy models or our partner models or our clients' models. You're able to apply that solution to your specific use case to improve robustness against adversarial attacks.
Nice. I know another area that you handle is explainability in AI. First, what is explainability? If you could give a quick definition, then how does Modzy use this to help people?
Very good question. So what we mean by explainability is how can we explain what the model predicts? So these neural networks or deep learning models are usually very, very complex. You can think of it as a black box, really, where an input goes in and output comes out. But just like human brain, the connections inside a deep neural network is so convoluted on the number of neurons and decision-making processes happening within the black box that the set of all the possible outcomes are so large that you and I cannot. It's different from an Excel file where you can just look at rows and columns and extrapolate something. These systems are very complex. So we use AI explainability to then make sense of how these models make their predictions. For example, going back to the image classification use case, there is a prediction produced by the model. So which class does the object within an image belong to? But then you can also explain why. For example, you can explain which pixels in the image did the model look at before it made its predictions. This is a very simple example of what explainability means. And then you can make sense of it. So if you are predicting that this image belongs to the car class, for example, is the model actually looking at the car itself, the doors, the wheels, the things that you and I would notice before we make our decision whether this is a car or not? Or is the model actually looking at the background, the house behind the car parked on the street? In which case, then your model is biased. You need to work on that. You have to figure out why the classification decision is based on something that's unrelated to the object itself. So explainability, in short, is a way to explain the decisions and predictions made by the AI model.
So I know a lot of times with AI, bias is a big thing that will on social media or in general, when people see it, can really hurt your company, brand and such, because no one wants that. So how do you work with teams, or does Modzy have a way to help pair explainability with fairness to reduce bias?
Yeah, definitely. So we have a specific ways of dealing with bias depending on the type of model and data set and objective. And AI explainability is a big part of it, where we look at predictions on large data sets and we average out what mattered to the model and whether that average outcome of what mattered to the model was biased or not. And if it was biased, how do you retrain and how do you improve that? How do you create a new data set? How do you maybe add noise to your data set? How do you add features or remove features that contribute to bias so you make sure that your model is less biased? Our adversarial work and explainability work both contribute to fairness and the ethical aspect of the models that we develop.
So if someone's listening to this, that's why I love speaking to companies. You probably speak to a lot of different companies and a lot of different clients. So are there any particular industries or areas where you see the biggest need for embedded security and defenses?
Oh, yeah. So autonomous cars, anything autonomous related really comes to mind, because once you automate a process you want to make sure that what you're giving the task to, that the system you're giving the task to is performing as expected, because privacy, security, all those issues that may come up if that system is compromised. Defense is another one. You want to make sure if you're deploying AI models for mission critical objectives or goals or mission critical environments, you want to make sure that the AI system is doing what it's supposed to do. Those are two big examples. With IoT, Internet of Things, your automated cities or automated traffic control, all those things, or air traffic, for example. As we are using AI systems more and more in these specific applications, you want to make sure that your AI system is secure, because now they're replacing some of the mundane tasks that humans used to perform, and you're relying on systems to automate these processes, and you want to make sure that they're performing as expected.
So I know typically with security exploits, when people get into the system, a lot of times the company doesn't know for months. It could even be years. So does Modzy actually help you detect quicker, or is it before it actually gets into your code base? Like, how do you recover something like a poisoning attack, I guess is the question.
So for the poisoning attacks, we make sure that, we have that filter. So every time you run the model on your data set, you're checking for possible poison attacks. We provide governance for AI models, meaning we produce logs of all the runs, all the data used, all the outputs that were produced by AI models. So a human being as the supervisor can frequently check those logs to make sure everything looks normal. We also provide drift detection, which is an entirely different field, but basically it gives you an idea of how your model is performing over time and if it's drifting from the expected performance. So we do provide a couple of different options for the users to actually check the AI model's performance and make sure that everything is intact and behaving correctly.
So another struggle I see is when you work for a big company, you have data scientists, you have developers, you have business analysts, and you have, your CEO, CTOs. How do they all communicate around this together and kind of collaborate with one another? Does Modzy, is it a platform that allows data scientists to speak with the developers easier in a way that people can all collaborate together and get the pieces they need without having to dive into each other's domain?
Exactly. So that's exactly the goal. So we have the technical data that the data scientists may need to run an AI model. And then we have the administrative side of the work where you just want to look at the outcomes, the type of computation that your model is performing, the expense, the cost, the people management who is running what model. So yes, we provide a range of possibilities for a big firm or company to use our platform depending on the task you're assigned to in that firm for a specific application. Yes.
So this may be like an odd question. Sometimes people don't know they need something. So how would someone listening know they need a solution like Modzy?
I think as companies start using AI more and more, this becomes obvious. This is the very first problem that comes to mind. You end up having a lot of data and many, many different data science models and AI models. And you need to unify the place you keep all these models. You need to give it order. You need to have a platform where you can actually use these AI models over and over and look at their predictions and summarize the conclusion that you're interested in or summarize the predictions that you get. So as different companies start using AI more and more, one of the very first problems that they face is what Modzy provides a solution for, which is how to unify all these large data sets, large models, and large outcomes, and how to manage them.
Okay, Dr. Arash, before we go, is there one piece of actionable advice you can give to someone to help them with their security AI testing efforts? And what's the best way to find, contact you, or learn more about Modzy?
So I guess my best piece of advice is to make sure I'm going to give a technical advice, to make sure that the way you're training your models is not the traditional way of doing model training that's outdated at this point. It's good to consider performance, but also bias, ethical issues, and also adversarial robustness. So not only do you want to look at the prediction accuracy, you want to also look at how you can explain your model's outcomes and how you can use that to explain the bias innate in your process and how to deal with that. You can also want to make sure that not only your model is making correct predictions on clean data inputs, but also on adversarial input. So model development in the field of AI and data science is now about performance, robustness, and lack of bias. Those three objectives should be in mind when you develop your AI models. In terms of how one can find more information on Modzy and my work, you can go to modzy.com. And my specific research work is under Modzy Labs. I lead the Modzy Labs for Modzy. That's where you can find our published papers. You can find any type of information you may need about Modzy itself.
Thank you, Arash, for your security testing AI awesomeness. For links to everything of value we covered in this episode, head on over to testguild.com/S26. And while you're there, make sure to click on the Try It Today link under the exclusive sponsor section to learn all about Micro Focus Fortify, which is the recognized market leader in application security. So that's it for this episode of the Test Guild Security Podcast. I'm Joe. My mission is to help you succeed with creating full stack security testing awesomeness. As always, test everything and keep the good. Cheers.
Thanks for listening to the Test Guild Security Podcast. Head on over to testguild.com for full show notes, amazing blog articles, and online testing conferences. Don't forget to subscribe to the Guild to continue your testing journey